Welcome back, my dear students. In the last session, we have finished chapter number 8, comparing quantities. In this session, let us learn chapter number 9, algebraic expressions and identities. Chapter number 9, algebraic expressions and identities. Now let us discuss about what is expression and what is identities. The first one is expressions. There are two types of expressions. The first one is arithmetic expressions. In arithmetic expression, we'll use for operations of mathematics. They are plus, minus, multiplication, and division. Suppose I'm writing some whole numbers by using the operation of mathematics like that. 2 plus 7 or 3 into 5 minus 1. This type of expressions are called arithmetic expressions. Now, second one, algebraic expressions. In algebraic expression, we will use English alphabet as symbols. Suppose I'm writing a number like that, 2a plus b or 3y minus 1 or 1 by 2 b plus 7. This type of expressions are called algebraic expressions because we are using English alphabet as symbol. Here I'm using a b, here y, here b. So these are the examples of algebraic expressions. See, next, terms. Terms are added or subtracted to form expressions. Suppose 5a plus 2b, 3x minus y. Here this is plus, then means adding. Here is minus, so this is subtraction. So this is a term, this is another term. So these two terms are added and we are forming the expression. And this also term and this also term. In between there is subtraction. So this is term and this is term. And this also, this is term and this is term. So terms are added or subtracted to form expressions. Here this 5a is called first term and this 2y is called second term. Here 3x is called first term and this minus y is called second term. Term sida huji haisi term mayam punsan naba natraga subtract tawraga expression semi haba. Next is coefficients. The numerical factors of a term is called its numerical coefficient or simply coefficients. Suppose minus 3ab. This is a term. In this term, the numerical factor is minus 3. So this minus 3 is called numerical coefficient. So here the numerical coefficient is minus 3. And this numerical coefficient we simply call coefficient. Again, let us suppose that there is 5x minus 10y. Here there are two terms. This is first term, this is second term. For these two terms, there are two numerical coefficients. The first one is 5 and the second one is minus 10. So here the numerical coefficients are 5 and minus 10. So here for this first term, the numerical coefficient is 5. So numerical coefficient of first term is 5. Numerical coefficient of second term is, we have to take sign also, minus 10. See, Gyantaraniko Matang, monomials, binomials, trinomials, and polynomials. Let us discuss about monomials, binomials, trinomials, and polynomials. First one is monomial. Expression that contain only one term is called monomial. Sida haisi term amakhatamag laiba expression do monomial kawi have example da 2x lae 2x the one term lay aduna monomial kaure. Suppose minus 10x sisu one term khatam lay sisu monomial kaurani. Next is binomial. Expressions that contain two terms is called binomial. Expression da term ani leiba taragadi adugumba expression dubu binomial kawi have. Example da suppose 2x plus 1 hai la sida two term lai first term na 2x ni aduga second term na 1 ni sigumba two term leiba expression sibu binomial kawi have. Gyan tare ko mathang da trinomial lage. Expression that contains three terms is called trinomials. Three term laiba expression dubu trinomial kaweba. Three term laiba term ahum laiba expression dubu trinomial kaweba. Examples of monomials are I have to pick monomial da di term amatang malay ni si term amalay sisu term amalay sisu term amalay sida iriba sing si monomial ngatani mathang da examples of binomial lage. Binomial da two term lay gatabani. Suppose 2a plus 1 two term lay re 3x plus y two term lay re sisu two term lay sisu two term lay adun de si binomials karani. Mathang da examples of trinomials are trinomial that the three term like ni 7a plus 3b minus 1 si first term ni second term ni third term ni term si ahum lai re adu ta di 6 si trinomial kaure. 3xy minus 10a plus 7 sisu three term lai re si first term ni second term ni third term ni sisu trinomial kaure sisu trinomial kaure si gyan tare ko. Mathang da polynomial asi. A polynomial is an expression that contains one or more than one terms. Polynomial da hai si term ama natragana term si ama dagi hena laiba taragadi adugumba expression du polynomial kaweba. Adu tar di sigi monomial sing si su sisu polynomial kawi sisu polynomial kawi sisu polynomial kawi. Hai badi polynomial da di one term natragana one term dagi hena laiba expression sing dubu polynomial kawi haba. Adu tar di monomial su polynomial ni binomial su polynomial ni trinomial su polynomial ni gyan tare ko yare ko. Next is like and unlike terms. Let us discuss about like and unlike terms. Like terms are here. This is like terms 3a 7a minus 10a. These are like term. Like term oi natraga oi dis ka maina khanga dagi hai kanda sida English alphabet sinai se a sinai se khoi na variable natraga na literal hai. Literal singdu manar magadi khoina like term ka hoisida a si manare aduna moi si like term ni. Di mathang da suppose 10x minus 2x 17x data x si manare aduna literal si manare aduna moi si su like term ni. Next examples of unlike term. Adu tar di unlike term di kamai tawi sida pyramid ba literal sing si manram da targadi adugumba term sing dubu unlike term kawi. Hausi sida irage. Suppose 5x 3y sida x ka y ga da manadre x ka y ga si literal natragana variable kawi. Aduna literal sida manam da targadi moi sing si unlike term kawi. Adi suppose minus ab 3ac sisu sida a b yawi aduga somdan a c yawi b ga c ga da manadre aduna c ga su hoji unlike term koi yani ko gyan tare ko. If you can understand this, now we can start exercise 9.1. So let us start exercise 9.1. Exercise 9.1, question number 1. Identify the terms, their coefficients for each of the following expression. In this question, it says that in the following given numbers, we have to identify terms. After that, we have to identify their coefficients. Okay, now let's try Roman number 1. Roman number 1, now terms. In this Roman number 1, two terms are there. The first one is 5 x y z square, and second term is minus 3z y. So we have to make a table like this, then here term, here coefficient, here the question number. So in this term, the coefficient is 5, so we are going to write down 5. In the second term, the coefficient is minus 3. We have to take sign also, minus 3. Now Roman number 2. In this Roman number 2, first term is 1, second term is x, and the third term is x squared. Here the coefficient is again 1. Here the coefficient is 1, here coefficient is 1. We have to write down like this. See, here how comes this one? Here this x is with number 1, here is 1, so this one is the coefficient of x, and here also there is 1, and we are not used to write 1, so this one is coefficient. Now Roman number 3, this. In this Roman number 3, the first term is 4x squared y squared, second term is minus 4x squared y squared z squared, third term is z squared. So for the first term, this 4 is coefficient, for the second minus 4 is coefficient, and for this third term here is 1, so 1 is coefficient. Bab tari ko se matang da Roman number 5 ki tauge si tauge. First term is x by 2, second term is y by 2, and the third term is minus xy. So here the coefficient is, here is 1, here is 2, so 1 by 2. Here this number 1 is with number 1, so the coefficient of y is 1 by 2. And here there is 1, so here the coefficient is minus 1. Bab tarani ko se khangi ko yare ko. Sige 4 ka 6 ka sim manare si skip taurage. Now let's write this question number 2. Classify the following polynomial as monomials, binomials, trinomials. Which polynomial do not fit in any of these three categories? Now let's write this question. In this question number 2, it says that these given expressions you have to classify as monomials, binomials, trinomials. After that, the question again asking that which polynomial is not fit in these three categories. Okay, now let us try this. Monomial means expression having one term, binomial means expression with two terms, trinomial means expression with three terms, and expression and polynomials are same. Expressions and polynomials are same. Question number 2 solution, and these are the polynomials given in question number 2. Now let's see. In the first polynomial, 1 to 2 terms are there. If a polynomial have 2 terms, there is called binomial. So binomials x plus y. Second one is 1 term, so monomial. And here 1, 2, 3, 4. So polynomials that do not fit in these categories is this a 4 terms, so this will come here. X plus x squared plus x cubed plus x to the power 4. Understand or not? Then next is this. Here, how many terms are there? 1, 2, 3. 3 terms means trinomial. This 7 plus y plus 5x. Next is how many terms? 1, 2. 2 terms is binomial. 2y minus 3y square. Here how many terms? 1, 2, 3. 3 terms. So trinomial. 2y minus 3y square plus 4y cube. Next, here count the terms. 1, 2, 3. Trinomial. 5x minus 4y plus 3xy. Here 1 to 2 term is binomial. So 4z minus 15z square. Here how many terms? 1, 2, 3, 4. So polynomial that do not fit in these categories are this will come because this have 4 terms. AB plus BC plus CD plus DA. Here 1 term monomial. So P, Q and R. Here how many terms? 1, 2 binomial. So here P square Q plus PQ square. Here how many terms? 1, 2. 2 terms means binomial. 2P plus 2Q. See, gyan tara ni ko. Next, let's try question number 3. Add the following. So here there are 3 expressions. Here comma, here comma. So this is the first expression, this is the second expression, and this is the second expression, and we are going to add these 3 expressions. Okay, now let's try this. Question number 3, add the following. Question number A, AB minus BC, comma, BC minus CA, comma, CA minus AB. Now solution. First, let's write AB minus BC. Here, AB minus BC. Next is this. So when we write the numbers, we have to write down the same term in the same line. So this BC we have to write on here, and here is plus sign, so plus BC, and next is minus CA. Here minus CA. Next is CA. This CA and this CA are like terms, so we have to write down in the same line. Here is plus sign, so plus. Next is minus AB. Minus AB, here is AB, so we have to write down in the same line. Now AB minus AB, now this will be 0. Here is minus, here is plus. If we subtract BC minus BC, that is also 0. Here is minus, here is plus, so we have to subtract CA minus CA, then that is also 0. So here the answer is 0. So 0, 0 means this is equal to 0. Here this Roman number 1 is over. Roman number 2 and 3 are same, so 2 and 3 you try. Now let me do Roman number 4. This L square plus M square plus N square, comma, N square plus L square, comma, 2LM plus 2MN plus 2NL. Now the first expression L square plus M square. Second one is this. This M square and this M square are like terms, so write in the same line. Next is plus N square. This after that this N square and this N square are like terms, so write in the same line. This L square and this L square are like terms, so write in the same line. Here is plus sign, so plus. Next is 2LM. So plus 2LM. This term and this term are different from that. So 2LM right here, plus 2MN here, plus 2NL here. L square plus L square. Here is 1, here is 1. 1 plus 1 is 2, so we'll get 2L square. Plus sign. Here is 1, here is 1. 1 plus 1 is 2, so 2M square. Here is 1, here is 1 again. If we add together, 2N square plus this 2LM plus 2MN plus 2NL here. This is over. I hope that you can understand that. Now let's start question number 4. Question number 4. A, B, C are there. A also subtract, B also subtract, C also subtract. So these 3 questions are same. So from these 3 questions, let me select B and let's try this B. Subtract 3xy plus 5yz minus 7zx from 5xy minus 2yz minus 2zx plus 10xyz. In this question, it is telling that from this number we have to subtract them. So we have to write down this first. So 5xy here, now solution, minus 2yz here, minus 2zx here, plus 10xyz here. Then we have to subtract this. 3xy here, 5yz here, minus 7zx here. This is subtract. In subtraction, we have to change the sign. So here is plus sign. Since this is subtraction, we need to change the sign. Plus sign, here plus sign, that changes into minus sign. This plus sign also we have to change the sign minus. This minus sign also we have to change the sign plus. Now we have to take this minus sign. 5 minus 3 is, we are getting 2xy. This is minus, we have to take this sign. Minus minus are same sign, so we need add together. 5 and 2 are add together, then we are getting 7yz. Since 5 is bigger, put the bigger sign. Here is minus, here is plus. The sign are different, so we have to subtract. From 7, if we subtract 2, then we are getting 5zx. Since 7 is bigger, we have to take this sign. So plus sign. Next is this. Plus 10xyz. Here, this question is over, and I hope that you can understand that. See, now let's start exercise 9.2. Question number 1. Find the product of the following pairs of monomials. Let's start Roman number 1. Solution. Product means multiply. So first monomial is 4, and the second monomial is 7p. So product means we have to multiply. 4 7 times 28, 28p. Understand or not? Next, let's do Roman number 3. First polynomial minus 4p into second polynomial 7pq. Let us multiply this. Minus 4 into 7 is 7, 4 times 28 minus 28. P into p is, here p power 1, here p power 1. The two powers are add together, then we will get power 2. Then next is q. Here Roman number 3 is over. Now Roman number 5. First polynomial is 4p, second polynomial is 0. 0 into any number is 0, so this will be 0. Understand or not? I hope that you can understand this. Now let's try question number 2. Let's try this question number 2. Find the area of the rectangles with the following pairs of monomials as their length and breadth respectively. Here the question says that the first given numbers are p and q. So if this p is length and if this q is breadth, then we have to find out area of the rectangle. Here 1, 2, 3, 4, 5 questions are there. I will select 2. The first and second I will solve it, and others are same, so you try the remaining. So here question number 2, solution. We know area of a rectangle is, the formula to find out area of a rectangle is length into breadth. Here p is length, so length is p, and q is breadth, so b represents breadth, so b is equal to q. Therefore area of the rectangle is length into breadth. Length becomes now p into breadth becomes now q. Then p into q is pq, and pq is the answer. Next is Roman number 2. This length is 10m and breadth is 5n. Therefore area of the rectangle is length into breadth, means length is 10m into breadth is 5n. Understand or not? Now let us multiply this. 10 into 5 is 50. M into n is mn. Here this question is over. I hope you can understand that. Next is question number 3. Complete the table of product. First monomials 2x minus 5x, 3x square minus 4x square minus 7x square y minus 9x square y square. Second polynomials are 2x minus 5x, 3x square minus 4x, 7x square y minus 9x square y. Now let us start to multiply. Here Let us do this in the textbook. 2x into 2x is 4x squared. 2x into minus 5 is 2 into minus 5 is minus 10. X into y is xy. This is getting 2 into 3 is 6. X into x squared is power are adding, then x power cube. 2 into minus 4 is minus 8. X into y is xy. 2 into 7 is 14. Then x into x squared is power are adding, then x cube, and next is y. 2 into minus 9 is minus 18. X into x squared is x cube. After that, y square. So others are same. You try this. Question number 4. Obtain the volume of rectangular box with the following length, breadth, and height respectively. Roman 1, 2, 3, 4 are there. These 4 questions are same. So let me select Roman number 3 and let me do that. Here the question says that if xy is length, 2x squared y is breadth, 2xy squared is height, then you have to find out volume of the rectangular box. So for this we have to apply the formula to find out volume of a rectangular box. The formula to find out the volume of a rectangular box is length into breadth into height, and we have to apply that formula. So now question number 4, Roman number 3 solution. Volume of a rectangular box, its formula is length into breadth into height. L is length, B is breadth, height is height. Here length is xy, breadth is 2x squared y, and height is 2xy squared. Therefore volume of the rectangular box is equal to length into breadth into height. Length we are writing this xy, into breadth we are writing this 2x squared y, and height we are writing 2xy squared. Now let us multiply this. 2 and 2 are multiplied, then we will get 4. This x will be multiplied by x squared, and again this will be multiplied by x. After that, this y will be multiplied by y. Again this will be multiplied by y squared. Now we are getting 4. Here is power 1, here is power 1. If we multiply x into x squared into x, power 1 plus power 2 plus power 1 is power 4, x power 4. Then y, here is power 1, here is power 1. 1 plus 1 is 2, 2 plus 2 is 4. So y power 4, and this is the answer. See, bhab tare ko. Next. In question number 5, there are 5 questions. 1, 1, 2, 3, 4, 5. All the questions are same. Obtain the following product. So let's do Roman number 3 and Roman number 4, and Roman 1, 2, and 5. You try it. So here I wrote the question. Obtain the product of, product means multiply. Now solution. Roman number 3. So the product product, the product is equal to, now this is 2 into next is 4 y into next is 8 y square, next is into 16 y cube. Now let us multiply this. 2 into 4 into 8 into 16, we have to multiply first. 2 into 4 into 8 into 16. After that we have to multiply y into y square into y cube. Now first let us multiply 2 into 4 into 8. 2 into 4 is 8, 8 into 8 is 6, 8 into 8 is 64, and 64 we will multiply by 16. If we multiply 2 into 4 into 8 into 16, we are getting this. So 1, 0, 2, 4. Here y power 1, here power 2, here power 3. If we multiply this, then we'll add the power. 1 plus 2 is 3, 3 plus 3 is 6, so we are getting y to the power 6. We are getting this. I hope you can understand that. Now, Roman number 4 is also same. Let's try Roman number 4. The product, product, the product is equal to A into second one is 2B into next is 3C, next is 6A, B, C. Now first let us multiply 2 into 3 into 6. 2 into 3 into 6. Next is we have to multiply A, here another A into A. Next is B, into here is another B. Next is C, C into C. 2 into 3 is 6, 6 into 6 is 36, so we are getting 36. A into A, here is power 1, here is power 1. We have to add the power, then A square. Next is B. Here power 1, here power 1. B into B is power 1 plus power 1, that is B power 2. Here C power 1, here also C power 1. So C into C means we have to add together the powers, then we are getting C square. Here this question is over. I hope you can understand that. Okay, for today, let's stop. All of you, thank you.